Have you got high electricity bills? Or are you wondering why your utility keeps charging penalties? There's one concept that answers all of these. It's called the power factor. Welcome to Engineered Simple. In today's video, I will explain to you everything you need to know about the power factor. Now, before we dive into this topic, let's consider these two scenarios. So now, for the residential homes, our electricity bills are usually based on the real power we use. But then, we also need small amount of reactive power in our houses. That is the fridges, TVs, kettles, blenders, fans. They use small amount of reactive power. But in today's video, I'm not going to go much into how they use it. One may ask, so why am I even explaining about all these stuffs? So I want you to get the understanding of why you need to know what real power is, what reactive power is, home appliances that need reactive power to operate, and all that. So now let's move to the other scenario. So the other scenario is a factory. So the first one was a residential house, then this is a factory. So in a factory, the electricity meter you have there charges them based on the real power they've used, the reactive power they've used, and their power factor drop. And I will also be using the beer and the foam scenario to help you understand what real power, reactive power, and apparent power is. So now, real power is the actual power that does the work. Real power is the power that lights the bulb, is the power that heats your oven, is the power that heats your iron, is the power that turns the shaft of your motor. Real power is measured in watts, and on the power triangle, it's the horizontal component of the power triangle. Now let's move to reactive power. The reactive power is the power that flows back and forth between the power source and reactive components such as what? Your inductors and your capacitors. So now, don't forget many electrical devices in our homes contains inductors and capacitor components. Hence, these components need reactive power to establish the electric or magnetic fields they need to operate properly. So our apparent power is the horizontal component of the power triangle. Apparent power is measured in kilovolts amperes. So unlike reactive power, which is measured in VAR, the VAR, and the real power measured in kilowatts, apparent power is measured in kVA. So now we'll be talking about the beer analogy. So now the full glass of beer represents our apparent power. That is the liquid part and the foam part. Everything combined together is our apparent power, measured in VA. Now, the liquid part of the beer represents our real power. This is what you take in to make yourself happy. So that is your real power. So it is the actual energy that what lightens your bulb. And lastly, the foam represents the reactive power. So the reactive power, so the foam there doesn't make you happy, but it comes with the beer. So the scenario here is the foam doesn't give you the happiness, just as reactive power won't do the main work. But the foam is needed in the beer, just like how we need reactive power to make our apparent power. Also, in my next video, I'll be talking about the power factor. But for today's video, we are done. See you in my next video. Drop your questions in the comment section if you have any. And if you found this video helpful, don't forget to click the like button and subscribe for more.